thousands of exoplanets around other stars, but Venus is still the planet most like Earth.
The surface of Venus is hot enough to melt lead.
Venus is incredibly hot. It has what we call a runaway greenhouse, where it's sort of the extreme state of what happens if you let a greenhouse go completely crazy on an Earth-like planet.
Venus is kind of a warning that we have to pay attention to what's happening to the atmosphere of the Earth. We don't want the Earth to become evil like Venus.
Venus and Earth are actually really similar in many, many ways. They're almost exactly the same size, and they have similar gravity. Venus is about 90% of Earth's gravity. We think that they both formed in a similar part of the solar system at about the same time from more or less the same materials. So they really should have a lot of similarities. We see they both have atmospheres, they both show the same types of geologic processes on their surfaces with volcanoes and tectonic regions, which is where the crust is moving around.
It's the only planet that is likely to be still geologically active in some of the same ways as the Earth. It has a similar bulk composition, it has an atmosphere, a huge atmosphere, one of the very few planets in our solar system to have a huge atmosphere.
That thick carbon dioxide atmosphere acts as a greenhouse, warming the surface to hundreds of degrees Fahrenheit, and pressures that are like being about a mile deep in the ocean. At Venus there's no magnetic field, whereas at Earth there is.
So Venus is kind of the Earth's evil twin sister. It shows how two worlds of similar size, similar density, not that far apart in terms of distance to the Sun, evolved very differently.
So the real core question comes down to is, what was it in Venus's and Earth's history that made these two similar planets take very different paths? And then how do we apply that to planets beyond our solar system and look at how understanding Venus could help us better understand what exoplanets are like and which ones are the ones that could potentially harbor life like Earth and which ones are those that are like Venus and are very hostile to life.
We believe that Earth and Venus formed around the same time in our original circumstellar disk. They are probably geochemically very similar because they formed very close to each other in the disk, much closer than Earth did to Mars. And from what we know about the geochemical similarities between Venus and Earth and Mars, certainly we believe that Earth is more similar to Venus than it is to Mars. We don't know that much about Venus because we haven't sent enough missions there as we have for Mars. It does have similar amounts of carbon dioxide in its surface and in its atmosphere compared to Earth.
Venus is, in some sense, the poster child for the greenhouse effect of carbon dioxide. It's a planet that has much more carbon dioxide than the Earth has in its atmosphere. And even though it is covered by this bright sulfuric acid haze, Venus reflects 70-something% of the sunlight that reaches it. So even though it's very close, it actually doesn't get nearly as much sunlight as you imagine because of that haze. Yet, it's got this crushingly hot surface. And the only way to explain that is because of the greenhouse effect of the carbon dioxide. Venus tells us that the greenhouse effect is a real phenomenon.
Venus in many ways is an extreme case of some of Earth's environmental issues. I mean, the most obvious one being global warming and the greenhouse effect, which is something we're all obviously aware of here on Earth because the amount of CO2 has risen above 400 parts per million, and that is causing global warming because of the infrared absorption of CO2. And yet, here's Venus, the Earth-sized planet next door, with an atmosphere that is almost 100% CO2. Venus, as far as we can tell, was a habitable planet for some time before it went through this runaway greenhouse transition.
imagine a graph where we have, temperature versus CO2, and so Earth is in this section over here, right, because we have this much CO2. So if we want to understand this process, Venus offers data up here, right? Another set of data points that we can use to sort of link how much CO2 do we need before this happens? When do we get into a position where we're really in trouble and there's nothing we can do about it except move to Mars?
We don't expect the Earth to turn into Venus anytime soon. Humankind is putting more and more carbon dioxide into the atmosphere, as humankind has been doing now for a few centuries, since the Industrial Revolution began. We know that the climate is going to get warmer. How warm it will get depends on how much carbon dioxide we put into the atmosphere. Humans are not going to be able to put enough carbon dioxide into the atmosphere to turn the Earth into Venus.
So there's this whole long-term cycle where the carbon comes out of volcanoes and ends up in the atmosphere and then gets pulled out by chemistry and made into carbonate rocks, which get deposited on the ocean floor and then subducted by plate tectonics into the interior of the planet and ultimately sort of heated and squished to the point where the carbon dioxide is released and then comes out again in a volcano. That's a cycle that takes millions of years, and it ultimately regulates the carbon in Earth's atmosphere. Of course, recently we've been perturbing it with our automobiles and smokestacks and things, but that's probably a temporary sharp perturbation in what is a multi-million year cycle that's been operating for billions of years. Now, compare that to Venus. We think that early on, Venus probably had a similar cycle because it has volcanoes, it had volcanoes, it's probably been volcanically active its whole life, and it used to, we believe, have an ocean, which facilitated those weathering reactions that pull carbon dioxide out of the atmosphere.
Part of the issue is that Venus no longer has an ocean. We think it had an ocean earlier in its history. We don't really know when water was lost. Having an ocean is an important part of pulling carbon dioxide out of the atmosphere. We think that Earth and Venus have similar amounts of carbon dioxide, but on Earth, those are locked up in carbonate rocks. And those carbonate rocks often are subducted back into the interior, sequestered in effect by geologic processes.
So you need an ocean, and we hope that we can find evidence in early Venus history of sequestering of carbon in rocks. That's what we look for on Mars. That's a lot of Mars work has been to look for those carbonate rocks on Mars. What Venus shows us without a doubt is that there is a relationship between the amount of CO2 you have in an atmosphere and the temperature.
Will the Earth become 500 degrees Celsius, 900 degrees Fahrenheit? That's really not likely to happen, but understanding chemical reactions in this very active atmosphere that Venus has is so important for being able to understand how climate change comes about, what are the important chemicals, what are the important processes. So we really have a lot to learn from the atmosphere of Venus.
For example, acid rain is a problem here on Earth because of sulfur dioxide from our smokestacks getting into the clouds and mixing with water and making strong acid. Well, Venus, again, is sort of the poster child for that condition, with clouds that are basically made out of pure sulfuric acid. And so it's a place where we can study this environmental problem, acid rain, in its most extreme manifestation. And to give one more example, another problem of our own making is the problem with the ozone hole and the ozone layer being eroded by these chemicals, these chlorofluorocarbons that we released into the atmosphere, where the chlorine gets loose because of ultraviolet light in the stratosphere and destroys ozone, which then becomes a threat to life here on the surface of the planet. Well, one of the ways we discovered the ozone layer was being eroded on Earth came about because we were studying the upper atmosphere of Venus.
Venus's atmosphere is so intriguing. We actually found the ozone hole on the Earth because people were studying chemistry of what was going on in the atmosphere, upper atmosphere of Venus.
Some scientists were trying to understand why isn't there more ozone on Venus? Why aren't there more oxygen compounds in the high atmosphere of Venus? And some other scientists said, well, we've seen these experiments with chlorine, and chlorine can destroy oxygen compounds. And then they came out with a paper saying, we think it's chlorine that is destroying ozone on Venus. Some other scientists saw that paper.
And it made them ask this question, well, what's going on in the upper atmosphere of Earth? Are there similar types of chemical reactions going on?
And they said, oh, that's interesting. What about these chlorine compounds that we're putting up in the atmosphere on Earth? Couldn't that? And they said, uh-oh, wait a minute. And that helped them realize what was happening and helped them sort of sound the alarm.
Look at that huge difference that made in terms of discovering the ozone hole on the Earth. And since people have taken action to actually stop putting those chemicals into the atmosphere that was creating such a destructive process.
And indeed, that's an example where we've responded in a healthy way to this knowledge that we were doing something to our planet and have taken measures to fix it. And it came about partly because we were studying this neighboring planet out of pure curiosity, trying to understand the chemistry there.
The link between innovation and expanding our thinking is not linear. In science and technology, you don't plan for that necessarily. You don't say, okay, I'm going to discover this great thing, and I'm going to start here, and at the end will be this great discovery. That comes from a lot of tries and a lot of failure. And if we don't push at the limits of what we can do as a society, we won't succeed. That's the way it works. That's what we do as scientists. That's why we sail across the ocean. That's why we climb the mountain. And that's why we should go to Venus.